All right, we are moving from central angles to inscribed angles, section 9.4. All right, and what I'd like you to do in your notes is pause this video, go ahead and read page 390. Then I'd like you to draw figure 9.18 and copy down theorem 9.13. After you go ahead and have that figure drawn and the theorem copied and you read everything, leave room in your notes for just one more picture. We're going to do all the notes together once you get these book notes copied down. All right, so pause it if you need more time. All right, you have some more notes to copy out of your book. You're going to copy down Theorem 9.14 on page 391. Again, leave room in your notes for us to do 2 example pictures. So we'll draw the circles out and write some things next to them. Then copy down Theorem 9.15 on page 392. Leave space again for yourself. And then copy down Theorem 9.16 on page 392. And again, leave that same space for yourself when we head over to our whiteboards. Please pause if you need more time. All right, it's time for that secret mission again. This time, when you think of the Lord, name a word that starts with M that comes to mind. I look forward to seeing what you come up with. All right, let's head over to the whiteboard. All right, the first theorem we're going to talk about is Theorem 9.13. And I know you have this figure drawn in your notes already, figure 9.18. Now, what does this theorem tell us? The measure of an inscribed angle. All right, I see an inscribed angle here. That is angle ABC. See how it's inscribed and its vertex B sits on the outside of the circle. And then it opens up to this intercepted arc. All right, so what does this theorem tell us? The measure of this inscribed angle is equal to 1/2 the measure of its intercepted arc. So that means that the measure of angle ABC is equal to the measure of 1/2, let's write it like this, 1/2 the measure of arc AC. That is what I want you to add to your notes with this figure. The measure of this angle right here is equal to 1/2 the measure of this arc. All right, fair enough. Let's take a look at an example of that. Now, I drew another inscribed angle for you right here, and I again called it angle ABC. Now, if I'm telling you that the intercepted arc is 60 degrees, how big is this angle? Now, if you want to say 60, don't, because this is not a central angle, this is an inscribed angle. So this angle is only 1/2 the size of this. So the actual answer is 30 degrees. Measure of angle ABC, 30 degrees. It's angles like this that we did last section, these central angles, where literally the vertex of the angle is right in the center, that the measure of the arc equals the measure of the central angle. So if this is 60 degrees, this arc, this angle is 60 degrees. I know it seems like an easy concept, but you definitely want to have these straight. The central angles versus the inscribed angles. All right, let's move on to our next theorem. All right, next theorem you have copied down is Theorem 9.14. And again, we're going to have a picture that represents the theorem, and then we're going to have an example picture. All right, so first let's look at the one that represents the theorem. Please add this to your notes. Anything on the whiteboard today, I do want you to put as part of your notes. All right, Theorem 9.14. If 2 inscribed angles intercept congruent arcs, then the angles are congruent. All right, so I drew 2 inscribed angles here. First one is inscribed angle number 1. See how it cuts off? This is its intercepted arc right here. It kind of, you can almost open it up past it if you really want to see. That's where it intercepts. And then here is angle 2, another inscribed angle. And look at this. It literally intercepts the same spot. This is the intercepted arc. All right, so they both intercept not only a congruent arc, they actually intercept the same exact arc, which means by definition, if these 2 inscribed angles intercept congruent arcs, happens to be the same one, definitely congruent, then the angles are congruent. So that means that angle 1 is congruent to angle 2. Now, it doesn't have to be the same arc. That's just the way I drew it in this picture. I could have had, make this picture kind of small. Let me zoom in a little bit. Let's just say I had this angle over here, and it was intercepting maybe an arc of, we'll do 60 degrees. And then I had another arc Another angle coming over here. And this inscribed angle intercepted this arc and this inscribed angle. So this is angle 1, this is angle 2. Angle 1 is intercepting this 60 degree. Angle 2 intercepting this 60 degree. Angle 1 and angle 2 would be equal there too. And they are not the same arcs, they're just congruent arcs. This picture, I had them intercept the same arc. All right, let's take a look at this example over here. The angles I'm mainly focusing on are this one and this one. Let's look. Inscribed angle number 1 is intercepting this 82 degree arc, which means it's half the measure. Angle 1 is 41 degrees. Angle 2 is intercepting this arc of 82 degrees, the same one again. So it's half of 82. So this is 41 degrees. Both angle 1, the measure of angle 1 and the measure of angle 2 are both 41 degrees, which is half the measure of the intercepted arc. And that is how theorem 9.14 works. All right, next theorem. All right, next theorem, theorem 9.15. An angle inscribed in a semicircle is a right angle. All right, let's look at our picture that represents our theorem. So first of all, how do I know I have an angle inscribed in a semicircle? So this angle right here, angle ABC, is intercepting this arc, arc AC. Arc AC is definitely a semicircle because you can see clearly that diameter AC goes right through the center of the circle. So if this is a diameter AC, and this inscribed angle comes up and intercepts this semicircle, that means this angle will be 90 degrees by theorem. Okay, so I'm just gonna write as part of our notes here that the measure of angle ABC is 90 degrees. We have another example of this happening. I have angle 1, which is an inscribed angle. This inscribed angle is inscribed in a semicircle, which means angle 1 automatically 90 degrees. Measure of angle 1, 90 degrees. All right, next theorem. Theorem 9.16. All right, this is a good one to learn. This is really helpful in problems when you're trying to find arcs and angles, basically inscribed polygons within circles. All right, so theorem 9.16. The opposite angles, opposite meaning across from. 1 is opposite to 3. 4 is opposite to 2. The opposite angles of an inscribed quadrilateral. Inscribed quadrilateral means this quadrilateral is completely inscribed inside the circle. We could say the circle is circumscribed around the polygon. The opposite angles of an inscribed quadrilateral are supplementary. Ooh, supplementary adds to 180. So that means that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Or I could say, or also I should say, the measure of angle 2 plus the measure of angle 4 in this picture equals 180 degrees. So opposite angles are supplementary in an inscribed quadrilateral. Very cool. All right, in this next example, make sure you have that as part of your notes. In this example, I want us to find a lot of missing information. All right, so I'm given that this arc right here is 64 degrees. I also know this angle is 82, this angle is 84. Why don't we start by finding the angles in our quadrilateral, and then we'll see if we can find some of these arc measurements. All right, so 82 and y are supplementary or add up to 180 degrees. 180 minus 82 is going to give me 98 degrees for this angle y. All right, 84 and x are supplementary because opposite angles in an inscribed quadrilateral are supplementary. 180 minus 84, 96 degrees for x. But how are we going to find the measurements of these arcs? I know this is 64. Let's start down here at this 82. This angle is an inscribed angle. It opens up here and here. So the 82 opens all the way up to this huge arc, which kind of makes sense because this inscribed angle is half the measure of this huge arc, which means this inscribed angle is 82 This huge arc is double that, or 164. Now, if this whole thing is 164, and I already used 64, that means A is 100 degrees. All right, so we're slowly solving the mystery here. All right, what angle do I want to use next? Let's use this 96. This 96 degree angle is inscribed, and it opens up to this whole arc right here. All right, what is 96 times 2? What would that be? Is that 192? Yes, 192. So if that's 192, this whole part is 192. Take away this 100, I'm left with 92 degrees for B. See how we're kind of using this as we go around and use our inscribed angles? All right, I got one more piece of the mystery. I'm thinking I could use this 98 because that opens up to it. I could use this 84 because that opens up to it. I guess I could go either way. Let me start with this 84. So let's take this 84 and open this up to this. And I know that 84, double 84 is 168. I know that I already used 64. So that would mean I have 104 degrees left for that part of the arc. Now, you know what else I was thinking? I could have just figured out what made 360. So does 104 plus 64 plus 100 plus 92 make 360? Well, you know what? Let's confirm it. You don't have to take my word for it. Let's check this out real quick. Does 104 plus 64 plus 100 plus 92 make 360? Absolutely. And a circle always makes 360 degrees all the way around. You know, while we're in the habit of checking, let's check our quadrilateral. Quadrilateral should always have 360 degrees. Does 96 plus 98 plus 82 plus 84 make 360? Absolutely. So it's a good way to check what we're doing here. All right, let's head back briefly to our slides. All right, it is time for your comprehension check questions. You're going to do numbers 1 through 8 on the attached PDF file. At the end of this, I will show you how to get to that. Let me just click to our next slide first because this concludes our notes. Nice job. Please remember you're going to submit this picture of your notes and the answers to your comprehension questions, numbers 1 through 8. All right, let me show you when you are on your classroom tomorrow, you will click on the link. I can even show you the actual link here. So when you get your assignment tomorrow, you'll click on the link. This worksheet will open. You can even go ahead and hit open in new window, just like we do when we want to see the comments. So I'm calling this our 9.4 notes. That's just a little recap of what we did. These are the questions you're going to answer. Questions 1 through 8. I know 6, 7, and 8 have quite a few questions in them, but you're going to answer questions 1 through 8 in completion. Do not worry about this highlighted part at the bottom. You are only to do questions 1 through 8. All right, awesome job today. I look forward to hearing how your notes go. Talk to you soon.